now we got it. Okay, I'm recording. Hopefully you can see everything and hear me. We should be good. Right? Can you hear me and see everything? Need another confirmation. Is everything working? Okay, good. Thank you. Alrighty, let me skip through a bunch of this stuff. So we'll continue learning about categorical logic. And so remember, there are those four basic types of statements, right? You're going to learn how to represent those on circles, basically. Just four different kinds of statements, right? And the names for them, hopefully getting familiar with them. Right? Universal affirmative, universal negative, particular affirmative, particular negative, right? So hopefully that's clear. Remember this. Right? This is going to come up because when we represent an entire argument, we're going to want to know what the subject term and the predicate term of the conclusion is, because that'll help us plot it. So it's good to know what a subject term is and a predicate term, okay? So keep that in mind, subject and predicate. Subject is the first part of the statement, right? The first category, diamonds, whatever it may be. Oh, good, for you, yes, hopefully, yeah. Again, you have to sort of, you still have to, in the same way, you have to be there for each step along the way, or it's not going to make sense. But it once you get it, it's a little bit simpler than propositional logic, for sure. Yeah. This is why they teach, you often learn Venn diagrams in high school. You don't very often learn propositional logic in high school. Or you might even learn it in an English class or something like that, right? So... Right, math people and English people. Yep, it's true. And even in philosophy, that's sort of the case. People tend to have one kind of, have tendencies towards one way of doing things. So, Venn diagrams, this is what you learned last time. Particular negative, very good, yes. Some people are not math people, is indeed particular negative, yes. Yeah. Okay, so remember how we're using these diagrams. Basically, you'll look at an argument. It's got to be right. The argument has to be right. If it has more than two premises, it's not going to work. If it's not using any of those statements, if it's not using all, some, or none, all, some, or no, it's not going to work. It's only going to work for category type statements. So it's got to be one of those four types of statements. Sometimes you just have to translate it into one of those four types of statements, right? So if I say Socrates is mortal, that's still going to work, but you have to translate it to something like all Socrateses are mortals, right? Something like that. Or all people identical with Socrates are mortal people. However you choose to say it. The point is that the subject term and the predicate term have to be nouns, right? It has to be a group of a category of things or objects that have a substantive noun attached to them. Right? So if you have any adjectives or anything like that, just turn it into a noun. That's usually not that hard to do, right? If I say all children are happy, right? Okay, you just turn it into all children are happy people, right? Something like that. It's not that hard to do. Just you have to keep that in mind. Okay, and then what you do is you plot it, and then suddenly you'll see, is the conclusion there as well or not. If it's a deductive argument and it's valid, then remember the conclusion's already entailed by the premises, and that means that if you represent them correctly, you will actually see the conclusion show up all on its own. That's how you test for validity using categorical logic. Okay. So last time I showed you that you can start thinking about this just by thinking about a single category of things like squirrels, right? Or students, or Socrateses, whatever it may be, right? You can simply make a circle right underneath what it represents, and that just means that this represents the class, the group, the category of all squirrels, of all the things that are named by the name underneath of it. Okay? So it's like you're putting a giant corral, right, a fence around all the squirrels and saying, well, they're all right here. And then I had you, we went through each of these, right, by combining two circles, right? One circle is, represents one category, but when you have a categorical statement, you're always talking about two categories, right? You're always talking about the category represented by the subject term and the category represented by the predicate term, the S and the P, right? So for each of these, you see an S and a P. Each of those is a category. So when you have a categorical statement, you're going to combine two circles. Right, so if you have the sentence, all squirrels are omnivores, you just make the two circles and you make sure that you put the subject term on the left. You see that? You put squirrels on the left circle, omnivores in the right circle. Okay. And then to make any kind of universal affirmative statement, what you're trying to say is that there's no squirrels at all outside of the omnivore circle, right? So we're going to represent that by blacking out that whole area. Anything outside the omnivore circle, inside the squirrel circle, there's nothing there. So we're going to represent that with blackness, representing a complete absence of all squirrels. Nothing lives in the squirrel circle outside of the omnivore circle. I hope you can see that that's equivalent to saying there are no squirrels that are not omnivores, right? It's almost as though that's what this is really saying if you look at it symbolically. The black means there aren't any non-omnivore squirrels, which is the same thing as saying, okay, so if you're a squirrel, you're an omnivore as well, right? So if you're part of the squirrel club, you're an automatic member of the omnivore club, right? You might say an honorary member. It's just representing the fact that squirrels are omnivores. That's all it's really saying, right? It's saying there are no squirrels that are not omnivores. So I hope that's clear. I hope you see what the blackout technique is representing, right? Again, this whole circle represents all the squirrels. If you round them all up, theoretically, you don't have, it doesn't really mean that. It's just a way for me to visualize it anyway, right? If you make circles everywhere, and you'll notice that the squirrels also exist in the omnivore circle, right? If they exist at all, they exist in the omnivore circle, but not anywhere out of it, right? If you're part of the squirrel club, you're automatically part of the omnivore club. Let's see what Anna's saying before I move on. Yeah, you can just memorize it too. It's just like for the truth tables, it helps if it really makes sense to you what the truth tables are representing. It helps if you understand why this means all SRP. It helps. You don't, strictly speaking, have to. You could simply memorize 4 rules, right? Just like you did for propositional logic, where you learn each of the 4 truth tables. And here you simply learn how to represent any all SRP type statements. They're all going to look like this. So if it doesn't make sense to you, simply remember all SRP looks like this. Yeah. So that's a good question, and it is very, very similar. Yeah. Okay. Okay, if this makes sense, that's better. Yeah. You know, things like that would be so much easier if we're all in a class together and I can just put stuff up on the blackboard and erase it quickly if I need to. You know, you can ask questions in real time. Everything's made a lot more difficult by doing this online, for sure. So that almost there-ness, right, It'd be so much easier to just push through that if we're all in the same space together. I mean, if it was always like this, I think we just all learn how to do it, but it's a learning curve for sure. I'm trying to learn how to teach this in this context. It's very difficult. Yeah. Yeah, I mean, we had to move on, right? That's the whole thing. I know I wanted that click moment to happen for everybody, but just can't. We have other stuff we have to get through as well. But maybe the click moment will still happen. Maybe it will still happen. We'll see. Yeah, it happens and then it went away. Yeah. Okay, let's see. This is all review from last time. So just remember categorical logic, four types of statements that we're going to be dealing with, right? So when you're representing arguments with premises and a conclusion, each of those premises and conclusion is going to have to conform to one of these four types of statement. Okay. What about a universal negative rather than a universal affirmative? Well, we still use the blackout technique, right? So if we wanted to say no cats are humans, what we're saying is there's nothing in this cat circle inside the human circle, right? You're not going to find a cat that's also a human. So we black out the middle. Exactly. To represent the fact that we don't have any cats that are also humans, right? So remember that middle area represents both, right? Being in both clubs. And in many cases, we're in two clubs, right? We're in the mammal club, we're in the human club, right? We're in the Americans club, although technically I'm not. I'm a resident alien. Anyway, that was just an example off the top of my head. You're in all sorts of clubs, right? Just by virtue of being a part of a category of things, right? So cats, they're parts of lots of clubs. They're parts of the mammals club. They're parts of the cute things club, right? They're not part of the human club. So we've represented that by just blacking that area. Cats are not allowed there, right? There are no cats who are also humans. So we just black that out. So every no SRP statement is going to look like that. It doesn't have to be cats or humans. It could be anything. Anytime you say no, this is that, it's going to look the same way. So then now on to the particulars. So with the particulars, we don't use the blackout technique, right, to represent absence. Rather, we use a little X to represent, yes, exactly, to represent at least one, right? That there's at least one member. And that is equivalent to some, right? Some in categorical logic means at least one. So then we're saying there's at least one dad, right? There's at least one member of the dad club who's also a member of the Grill Masters Club. You see how that works? Yeah. And again, it could be anything. It doesn't have to be dads or Grill Masters. Anytime you want to say, yeah, so he's not part of the Grill Master Club, right? Yeah. Right. So there's at least one. We didn't say it was your dad, right? So there's at least one dad out there who's good at grilling, great at grilling. I don't think I'm a grill master either. I've gotten better. I don't think I'm a grill master, unfortunately, right? But there are some, and that's what we're trying to say here. There are some dads who are grill masters. If we had wanted to say no dads are grill masters, we would have just blacked that all out to show that there can't be an X in there. Right? Once something is blacked out, you cannot put anything in there. Yeah. Steak is one of those things that took me a little while to get the hang of, and I realized it's complete minimalism, right? So you do leave the steak for as long as you can, but not too long, right? And the barbecue sauce, I would rather put that on after, because the barbecue sauce can start burning on the grill, all the sugars carbonize and stuff like that. Yeah, I like a good rare steak as well. I see. Yeah. So any particular affirmative is going to look like that. Anytime you say some, this, is that, right? It's going to be the same thing. Some dads are steak destroyers, right? You could have said that as well. Then S would be dads and P would be steak destroyers. Right? And the little X would represent your dad. There's at least one dad who's a steak destroyer. Yes. Okay, the last one. And again, we did all these, but... well, I'm glad we can laugh about stuff, right? It's good. So any particular is always going to be an X, because particular always means some rather than all of them, right? And some means at least one, right? At least one member of the group. So at least one member of the group books is not a bestseller, right? So where am I going to put the X to represent that it's not a bookseller? A bestseller, rather. Just to see if you're paying attention. Yeah, in the first circle, right? And outside of the middle area, right? So it's going to be in this circle, but not right here. We can't put the X there because that would mean some books are bestsellers, right? If I put it right in the middle, that would be a particular affirmative. But if I put it right here, it means that there's at least one book that's not in the bestsellers book, the bestsellers club. And there's at least one member of the category book that's not part of the category bestsellers. Okay, so put it right there. Okay, so that's review. So then hopefully you will either see why each of these, why the symbolism makes sense, right? If you look at the S, there's an S circle and a P circle that represent the subject and the predicate terms. They're each categories, and we're saying, you know, we're putting a circle around all the S's and a circle around all the P's, and then we're representing their relationship. Sometimes we want to say that all the S's in the circle are P's. So that means there's no S's outside the P circle, right? So that's all S or P. Sometimes we want to say that there aren't any S's that are also P's, right? No dads or grill masters would be that, right? We put it right here. If we said no dads, remember the example was some dads, right? Just giving an example as a universal negative. So if we want to say that some no SRP, then we just black that out to represent that. Some SRP means there's at least one member of the S group that's also a member of the P group, right in the middle. And if you want to say that some S are not P, you simply have to say there's at least one member of the S group that's outside of the P group. Okay? Yeah. You found your notebook? Good. Okay. But, you know, so if you understand what the blackout technique is doing and what the X technique is doing, then you could just think about what it is that you're trying to say, right? If you want to say all SRP, then you know you're going to use the blackout technique because you're not talking about at least one member. You're talking about the whole entire category. And then you're going to use the blackout technique, and then you have to think about, well, what am I going to black out? Am I trying to say that there's an S that's also part of the P circle? That's if we're down here. Am I trying to say that if you're part of an S circle, then you must be part of the P circle? Then you would represent it like this, right? This means you have to be P in order to be an S. Okay, and for each of them, hopefully, if you understand what the blackout technique is doing or what the X technique is doing, you understand why it makes sense that this represents each of the four types of statements. Okay? And if it doesn't, again, just like with the truth tables, have charts of this. Take a screenshot of this and print it out, whatever you need to do. Just have this as a handy reference guide, right? Either for studying or just for cheating, right? When you're doing the final or something like that. If you need something to look at, it's better just to get it all in your head, but have a quick reference guide for this, right? Okay, so now we're going to move on to the actual thing. You'll learn how to use two circles to represent any one of those four types of statement. And now what we're going to do is learn how to symbolize two statements by using three circles. Okay? And again, the way this works is we're not looking for a gremlin here. That's not exactly what we're doing. Although in a way you are, because if you see a different conclusion show up and not the one that's listed in the argument, then that's a type of gremlin as well, right? But that's just not the technique we're using. Even though the gremlin still shows up when it's not a valid argument, that's not the way that you're going to learn to identify valid and invalid arguments. Here it's a little bit more direct. Once you've plotted those two premises, and again, we're only going to be using two premises to do categorical logic, okay? Once you have those two premises plotted, if the argument is valid, you'll be able to just read off the conclusion using one of those four categorical type statements. You'll simply be able to recognize that it's there. Okay? And that's, because of this idea of logical entailment. It's just not possible for the conclusion to not be there if you have the premises. And using Venn diagrams allows us to really show that visually. Right? Whereas before, in propositional logic, you have to think about this in a very abstract way. Here, if you understand the symbolism, you'll simply see the conclusion show up all on its own. Right? Because, again, logical entailment is like that. It's already logically entailed by the premises. Because remember, that's what validity is, right? In a valid argument, if the premises are true, the conclusion must be true. So, first, just before we actually take a whole argument, let's see how it works if we just represent two statements. Okay? So we have two statements. All cars are vehicles. All vehicles are transporters. Okay? So if you were to do this using that chart, that should be pretty easy, right? They're both universal affirmative statements. So I think you know what these are going to look like. Notice that there is a term that's the same in both of them, right? Vehicles. So in statement number 1, the predicate term is vehicles. And in statement number 2, the subject term is vehicles. And this is another feature of categorical arguments, is that they do not work if there are more than 3 terms in there, right? We can only be dealing with 3 terms because we're only dealing with 3 circles, right? So there has to be a shared term, what's called the middle term, right? All these arguments, the 2 premises that are listed must have one term in common, or else it'll just sort of be automatically disqualified, okay? Again, because we're using category symbols, these circles, and to do the Venn diagrams, we can only deal with 3 circles, at least the way that we're doing it. So that means you can't have more than 3 categories, right? So that also means that if you have 2 statements, you're going to have to reuse one of those categories. In this case, it's vehicles. Okay? They're all going to be like that. So what kind of, I just told you this, but see if you're paying attention. What kind of categorical statements are both of them? They're both the same. What do we call them? Good. Yeah. Universal affirmative and all SRP type statements. Good. Yes. So then this should be pretty easy, right? You just, again, you can just look at your charts. What do those type of statements look like? Well, they always look like this, don't they? Right? All universal affirmative statements look like this. Right? The subject term that's outside of the predicate term is all blacked out, meaning that if you are an S, you must be a P. Right? If you're a car, you must be a vehicle. If you're a vehicle, you must be some sort of transporter, right? Just true by definition, right? So we have those two types of statements, but let's use abbreviations for the subject and the predicate term so we can keep track of what they all mean, right? So if we have two statements, we can use C for cars, right? V for vehicles, and T for transporters. So now do you see how we simply did what we already learned earlier? We took two different statements and made a separate Venn diagram for both of them, or a separate, representing it with the circles. So the one on the left says all cars are vehicles, and this one says all vehicles are transporters. Good so far. That's just what we already learned earlier, right? That's just turning any one statement into its symbolic form like this. Right? That should be straightforward. But now notice that we have a V in both of them, right? We have vehicles represented in both of the circles. So why don't we just combine the two circles, or the two statements, into one statement that involves cars, vehicles, and transporters? Right? Again, there are just three categories here, so why don't we just use three circles, right? We can easily do that, right? You just use three circles like this. So this is very important. You see that top one, the top middle circle, is always going to get the name of whatever both of them have in common. That's called the middle term. Okay? Does everybody see this? We have two statements. They both involve vehicles. They're also different. This one involves cars, and this one involves transporters, but they both involve vehicles. Since they both involve vehicles, that's the middle term. And the middle term, we always want to put it right in the middle like that. Everybody got that? Okay. And then we label the left one C and the right circle T. Make sense so far? Well, then let's just look at the three circles and use the black cow technique to represent the statement, all cars are vehicles. And when you do that, just ignore the V circle entirely. Okay? You're not going to be affected by it. You're going to fill it out in the same way. All cars are vehicles. What do we have to do to represent that? Yeah. Just black out everything in the C circle. But what? Except for what? Yes, I'm going to black out the C circle, but which parts, right? There's this, there's this, there's this, there's this. It's divided up into 4 parts now. First what? Yes, the first circle. Just the big parts. What about this part right here? Right in the middle. Do shade it, right? Because it's the same thing as before. Like I said, you can... Oh, sorry, I had said ignore the V circle. I'm so sorry. It completely threw everyone off track by that. What we're trying to represent is all cars are vehicles. So what we can ignore is the T circle. I'm so sorry. Okay, let's start all over. Right? We've got our three categories. We've got our three circles. First, let's represent the statement, all cars are vehicles. Now, we know that when you have a universal affirmative statement, you cross out, you black out everything in the car circle that's not in the vehicle circle. Like that. Including this little middle area. Because if that was left open, that would allow for the possibility that there are cars that are not vehicles. Right? But the statement is saying cars, all cars are vehicles. So we have to stick to that. Do you see? It's very important that you get that. That you simply ignore the second one when it comes to representing the all cars are vehicles. You're just looking at this circle. Lost. Okay. Let's go back for a second here. You got this, right? This is just representing each of the sentences on its own. Right. Now what we want to do is combine both of these, right? They both have two circles. Let's combine them. Let's smash these premises together into one big super diagram. But we don't need to make two different vehicle circles. We can just make one vehicle circle, right? So we end up with three circles. One for each of the categories. Okay. With me so far? We haven't represented we haven't represented all cars or vehicles yet up here. We have not represented all vehicles or transporters yet up here. We simply just have the three circles for each of the categories that we're talking about. We're talking about three different categories. We're talking about cars, we're talking about vehicles, we're talking about transporters. Okay. So far. That's what we got so far. Yeah, it's an all SRP type statement. That's right. So when you look at the statement, all cars are vehicles, right here, this is what it looks like, right? We have a C circle and a V circle, and the C circle is all blacked out, except the part that's in the C circle. Now notice, we have the C circle and the V circle right here. You see that? The C circle. It's just like, take this and just angle it like that, right? It's the same thing. This is the same as this. So fill it out the same. Ignore the T circle. Just fill it out just like we did here. It is recording, yes, yeah. See. Well, no, it said all cars are vehicles. Right? All cars are vehicles. That means there are no cars outside of the vehicle circle. If we look down here, this is how you represent all cars are vehicles. Right? Yeah. And what you can simply do is take this right here and just whoop, like that, and then you can superimpose it on this right here. You see that it's the same. And we've represented the exact same thing here as we did here. And you can just ignore the T circle over here for now. All we're worried about is all cars are vehicles. And we're going to have to do the same thing. Here's the vehicle circle. There can't be any cars outside of the vehicle circle. We can't have cars here, because that would make a non-vehicle car, and that can't be. We can't have one here either, right? That'd be a non-vehicle car. All cars, if you're a car, you must exist in this space somewhere. If you're a part of the car club, you must be part of the vehicle club. If we left this open, then that means you could be part of the car club, not part of the vehicle club. Right? That's no good. That's not what we're trying to say. So again, all we're really doing is taking this statement right here, all cars are vehicles, and we're representing it right here. Does that make sense now so far? You can simply ignore the T's, for the T circle for now. simply know how do you symbolize a universal affirmative? Well, you black out everything in the subject term that's outside of the predicate term. So we're doing the same thing here. It doesn't matter if there's a circle here. You followed the rule. Black out everything outside of the predicate term. Shade in the V that doesn't overlap. Oh, next, you mean when we get to all vehicles are transporters? Maybe that's like, yeah, we'll see in a minute, but let's not get ahead yet. Just so far, just representing all cars or vehicles. Yeah, this right here says the same thing as this right here. It just has this extra little circle to annoy you and distract you, right? But when you're plotting any single statement, just ignore it, right? Just look at the two circles that you're dealing with and make it look the same. Right? These are the same. Yeah. Now we do the same thing for all vehicles or transporters. And we just have to do the same thing. You can ignore the C circle. Just look at the V and the T, and you realize, okay, to represent this, I have to black out everything in the V circle that's outside of the T circle. Right? So that means I have to black out everything in the V circle that's outside of the T circle. Like that. You wait a second here. Hopefully you can see. Okay, yeah. Yeah, exactly. Any type of universal statement is like that. You black out everything outside of the predicate circle. And we did the same thing right here, right? All vehicles are transporters. Okay, black out everything that's outside of the predicate circle. Right? That means if you're a vehicle, remember, a vehicle has to be inside this circle somewhere. All the vehicles in the world are inside the circle. Can they be outside of the transporter circle? Not according to the statement. The statement is saying all vehicles are transporters. So that means there can't be any vehicles here. If there's a vehicle at all, it has to be in this space right here. Right? And so we represent this up here, right? We did the same thing as we did for this one. This was just this plotted this way. This is just this plotted this way. See? The V and the V, the T and the T, they look the same. It's just now we have this overlap with the first premise. But so far, that's all you've really done is you take two different statements and plot them all together on one super diagram, which you can do because there are only three categories, right? We're dealing with cars, vehicles, and transporters. If we had any more, we wouldn't be able to do this way, right? But we're never going to do more, so it's always going to be like this. So you end up with this, right? Now you've represented two different statements into one super diagram. Right? You've represented that all cars are vehicles, and you've represented that all vehicles are transporters. That's just symbolizing. That's just the rules. Okay. But we can look at this now and see if it's telling us anything else. And now that you know the rules for what universal affirmatives look like, universal negatives, particular, affirmative, negative, etc., what they look like, does this say anything else? We've had statements about cars being vehicles and vehicles being transporters. Does it say anything about cars and transporters? Yeah, Anna, you're on the right track, but you want to stick with vehicles, transporters. You don't want to go vehicles that transport and things like that, because then you're introducing a whole other category, right? The categories are already set. So I'm saying this to Anna. You're on the right track. but you need it. So, well, let's see. All vehicles are transporters is already there, right? All vehicles, that's already one of them. Um, Maggie said all C's are T's. Yeah, that's right. So when you look at this circle, are there any cars outside of the transporter circle? Look at the car circle. Can you have any cars outside of the T circle? Yeah, they are, but we've already said all cars are vehicles. Right? And we've already said all cars are transporters. So we've already said those things. We just want to look at the C's and the T's now. We don't want to do any of this and stuff. We're not going to do that, right? And was in propositional logic. We're not going to be doing that here. Right? Yeah. Now, this is not to say that you're not wrong, that you're wrong at some basic level, right? You could make that conclusion, right? If it's true that all cars are vehicles, and it's true that all vehicles are transporters, then you could say all cars are vehicles and transporters. It's not wrong in terms of logic, but it's not how categorical logic works, right? So you just can't have those and statements in there. Yeah, the car and transport thing is shaded. Right, so if we're not making these and statements, don't say what cars are this and that, and don't say transporting vehicles. No, you're introducing new categories. The three categories we have are vehicles, transporters, and cars. We don't have anything called transporting vehicles or transporting cars or car vehicles. Those would be their own categories, right? We're just dealing with three categories. We've represented all cars are vehicles. We've represented all vehicles are transporters. Now, somebody's already said the answer. I think Maggie already said the answer, but we have not made a statement yet about cars and transporters. So I'm setting you up here. I'm asking you, is it possible to be a car that's not a transporter, according to this diagram? All cars are transporters, right? Exactly. No, it's not. So that means all cars are transporters, right? Again, this little white area means that if you're a car, if anything is a car, it must be right here. What is it inside of? Well, it's inside of the vehicle circle, of course. And we did say that. We said all cars are vehicles. We already said that, so we don't need to say that again. But it's also inside of the transporter circle. And that's something we haven't said yet, right? All cars are transporters. Yeah, so if your conclusion was all cars are transporters, right, then that would be it clicked for right now, right? Yeah. But it just showed up all on its own, right? Once you've stated that all cars are vehicles and all vehicles are transporters, it just follows logically. Okay, well then, since we've shaded everything out, we've represented everything, that's the only possibility left for a car. Right? A car must be a transporter. Right? That's the only place for a car to exist. Yeah. So if that were the conclusion, if this was your initial argument, and all you did was represent premise number 1, right here, and then premise number 2, right here, then you can check, does the whole thing, now that I've done that, does it also say that all cars are transporters? In other words, if I look in the car circle, will there be any cars outside of the T circle? No, everything's all blacked out. Right? So simply by assuming the truth of the premises, by representing them as true, we can also see that the conclusion has to be true. Yeah. So the conclusion just showed up all on its own. wait a second for you. Okay. Yeah, we'll do another one for sure. So let's start this time with the whole argument. I just wanted to start with just the premises, and then you could see that a conclusion did show up. Usually we'll start with a whole argument. Right? We've looked at this one before, I think. All cheaters are liars. Some humans are cheaters, so some humans are liars. Again, I think for many people, if you look at this, you intuitively get it, right? You can kind of tell that that makes sense. If it's true that some humans are cheaters, but all cheaters are liars, then it would follow that some humans are liars. And so hopefully you'll see that we should get the result we want. If we symbolize these two premises, the conclusion should show up all on its own, because it always does that in a valid argument. Okay. Well, yeah, so when you transfer the middle term, so I'm saying, like, let's just skip over. I just wanted to show you the two statements to combine them into one. The shade, let's see if we get to that. I'm not entirely sure if I know what you mean, Maggie, but we'll see if we get to that, right? So for now, simply you look at the argument, make sure that there are only three categories, right? How many categories are there in this argument that I just gave you? Well, there's cheaters, liars, and humans. So that's good, right? If there were more terms than that, we couldn't do it. If there were less terms than that, we couldn't do it, right? If there were less categories, we need three categories, no more, no less. But we have that in this argument. We got cheaters, liars, and humans, okay? So we know we just need three circles. Is that good? Make sense? Right? If I give you an argument and I ask you to put it into symbolic form, your first step will be make sure that there's only three categories. Right? Once you know there's three categories, go ahead and make three circles that's going to represent each of those categories. Yeah. And when you do this, you can pretty much ignore the conclusion. Okay. Now the conclusion will tell you, I'll get to this in a second, what to put on the left, on the right, down here. Okay. But all we're really going to do is symbolize, right, using the shade technique or the X technique, both of these statements, and then we'll see if the conclusion shows up. So the first thing you do is, you want to label each of these circles appropriately, but you got to do it right or it gets confusing. Okay. So this is very important. Remember what this top middle circle is? I think that's what you were asking about, Maggie, right? Yeah. Yes, cheaters, C, exactly, right? That's what they both have in common. You look at both of the premises, and whatever they have in common, that's your middle term, and you put it right in the middle. Right? It has a certain nice symmetry to it that way, right? Here's two categories. Here's the one that they both have in common in some way. So let's see what it is. Okay. So let's first do the top middle one. Okay. So that's C. That one's always really easy. Look at both of the premises. What's the category that both of them have in common? Put that right in the middle. And then yes, H for humans and L for liars at the bottom. This is what I was trying to fix earlier, and I didn't have enough time. Right before class, I wanted to clarify something, and I ended up just making it kind of worse. Right. So this is what I wanted to say is, you see the bottom two? What are you going to put on the left? What are you going to put on the right? Well, here you look at the conclusion, and you put the subject on the left and the predicate on the right. Right. So what was the conclusion again? Oops. It was some humans are liars, right? That was the conclusion. Yeah, exactly. Yes. So the middle term, really easy, right? Whatever both of them have in common, you put right here. What you put here and the left and the right, look at your conclusion. What's the subject term in the conclusion? Put that right here. What's the predicate in the conclusion? Put that right here. So Cassandra is exactly right. Okay. So this is just to remind you, that's what the conclusion was for this argument, right? The conclusion was some humans are liars. So just put the H and the L appropriately. Okay. So that's how you label them all, right? Notice we have not symbolized the premises yet. We haven't symbolized the conclusion. We've just symbolized the categories. Okay. So when you look to the conclusion, that's just to help you set it up, the initial setup. Right? After that, you'll forget about the conclusion until the end. Right? Oh, okay. You're on to representing the. You are trying to represent the premises already. Yeah. Give it a sentence. 1 minute here before we get to that, right? I just want this to be clear. When you initially set up your 3 circles, the middle term, right, the one that both of the premises have in common, goes at the top in the middle. Then look at the conclusion, put the subject term on the left and the predicate on the right. Okay. Now, right, well, let's first do the universal one. Because Anna, were you trying to do 1 or 2? Because remember, oh yeah, you were trying to do it. But why are you doing some S or P? Okay. Yeah, remember, we don't want to represent the conclusion. The conclusion must show up on its own if it's going to be a valid argument, right? We want to represent the premises using the X's and the blackout. Right? This is just the initial setup. How do we set up the circles? How do we set up the diagram so that we can then fill it out? We got to all do it the same way, in a standardized way, or else it gets confusing. So the idea is that you put the middle term right in the middle, and you put the subject term of the conclusion on the left bottom, and the predicate term of the conclusion on the right bottom. Okay? So then, yes, all cheaters are liars. So we're looking at this circle right here, and we're looking at this circle right here, and we're going to use the shade technique, the blackout technique, and we can just ignore H altogether. Right, so shade in C that does not overlap with L, right? So yes, exactly. Shade out everything in C that's not in the L circle. That means that if you're a cheater, you got to be somewhere in here. Yeah, I think you got it. Yeah, I interpreted that as L, Cassandra. You got it. All right, like that. Well, it by default it does, right? Because we already know that to correctly represent that all cheaters are liars, we can't leave this open right here, right? This part of the H circle we have to. It leaves open lots of other possibilities, but you just cannot have a cheater that's outside of the liar circle, right? We're saying all cheaters are liars, so that means there's nothing at all outside of the liar circle. So that means we have to shade this part. Yeah. But that's not saying a whole lot about humans yet, right? There's all sorts of other areas, right, where a cheater could hang out here, right? There's all sorts of other possibilities. But if we're just want to represent all cheaters are liars, we have to make sure that everything outside of the L circle in the C circle is shaded. Right? There are no cheaters outside of the liar circle. That's what all cheaters are liars means. Okay? And again, if you just looked at your universal affirmative, it would look like that. It would just, instead of being up like that, it would be like this, right? But it's the same basic thing. All of this part is, everything that's outside of the predicate circle is going to be blacked out like that. Okay? So that's your first premise. What about some humans are cheaters? So again, we can try to ignore the L1. At some point, you won't be able to ignore. We'll get to weird sort of scenarios. But if we just wanted to say that there's at least one human, right? An X, right? At least one human who's also a cheater. Where would I put that X? You mean right here? Yes. Yeah, and remember, this says some, right? So if you say some, you're not going to use the blackout technique. Some means at least one. And at least one means a little X. Yeah. So some humans are cheaters, right? That means there's at least one member of the H circle. There's at least one member. So we're going to put an X somewhere in the H circle. Where? Well, some of them are cheaters. So that means we have to put an X in the H circle that's right here in the C circle as well. See that? Once again, it's the same sort of thing. If you were to just look at the H and the C circles, and if I was just saying represent all humans are cheaters, or rather some humans are cheaters, that's what you do. You'd have an H circle and a C circle, and you'd put an X right in the middle. Right? It just happens to be that this part of it was shaded out. So that means we have to put it right here. So look, we're kind of being forced to put it into the liar circle as well, right? It's that forced nature that gives us a brand new conclusion. It's the fact that the choices we're making now when we represent the premises will have logical entailments. They'll have logical conclusions. It means, for example, that there's at least one member of C and L. Right? You had the wrong middle. Okay. Did you put it right here, maybe? Because remember, it says some humans are cheaters, right? So this is not a cheater circle right here, right? It's got to be inside this circle. This is the cheater circle. So it's got to be inside the human circle and inside the cheater circle. Yeah, at least one human is a cheater is what that's equivalent to, exactly. So when you read some, just in your mind right away go, that means at least one. And we represent that at least one with a little X. Yeah. Okay, yeah, you see how it came out wrong. Well, that's good. Yeah. And this takes a little bit of getting used to. I mean, I said that for some of you this is going to be easier. It doesn't necessarily mean that it's easy all around, right? So now we've represented both of the premises, right? So then we just have to check if the conclusion is there, right? Remember, the conclusion was some humans are liars. What does that look like just on its own? Well, it means you have a human circle and a liar circle, and you're going to put at least some. That means at least one, right? Rather, some means at least one with a little X. So that means you would expect to find an X somewhere in the human circle and also in the liar circle. Did we find that? It's represented. It's there. Right? It's there. It's right here. So it's valid. The conclusion showed up all on its own. All we did was represent some humans are cheaters with this. And then when we represented all cheaters are liars with this. And then when we look at the relationship between humans and liars, we find that there is one represented automatically just by representing the other ones. All of a sudden, it automatically says there's at least one member of the human circle who's also a part of the liar circle. You got it. Good. Good. And so now, so you see what logical entailment means. It means that, you know, if you've represented both of the premises as being true, then the conclusion's being represented as being true as well, automatically. Yeah? It was the same for propositional logic. It's just nice to have a visual of that, right? Look, what did we do? Did we ever write down the conclusion in symbolic form? Not on purpose, right? All we did was write down the premises in symbolic form. We represented the premises on these circles, and then the conclusion was just there, right? That means if the premises are true, then the conclusion must be true. So it's valid. Okay. Here, let's do one more. No humans are fish. No humans are cold-blooded creatures. Therefore, no fish are cold-blooded creatures. Can you guess if we're going to find the conclusion represented here or not? Do you think we'll find the conclusion represented? Do you have a guess? Do you think this argument is valid? Probably not, huh? Yeah, it does not look like it. It's one of those ones where it's kind of easy because you know that the premises are actually true, but you know that the conclusion is false. So you know that it can't be valid, right? In a valid argument, that's just not possible. But here, you know, independently of logic, you know through your own empirical senses, through your own understanding of the world, you know that the premises are true and the conclusion is false. So you know just ahead of time that it's not going to be valid. But let's see what that looks like, right? We'll just do the same thing as we did before. First, check to see how many categories there are. Okay, let's see. There's humans, there's fish, there's cold-blooded creatures. Perfect. 3. So we can use 3 circles like that. Right. And then I should have just asked you this before I put it up there. But you know what to do next, right? You look for the middle term. You look to see what they both have in common. And they both have in common humans. Right? Yeah, exactly. What's in common, and in this case, that's humans. So you put that in the middle. Right? That's what they both have in common. It's humans. And then what do we put down here? How do we figure out, yes, F and C, and why? Why do I put a F and a C here? What's the rule you're following? The subject and predicate of the conclusion, right? That's the only time you really look to the conclusion, is when you're initially setting it up, and then at the very end. But you're not representing the conclusion. You're just looking at the conclusion as a way to standardize what we're going to make the left circle and what we're going to make the right circle. No, we can't make it H, obviously. But we could reverse them. It's just we want to all do it the same way. So you put an F and a C. Does the placement, not if it's in the premises, right? Is that what you mean? When you're looking at the written out premises there, it does not matter. Yeah, it does not matter. All that matters is it the term that they have in common? Yeah. Is there a category that's being used in both of the premises? If there's not, then you can't do anything. If there is, it doesn't matter where it appears in the premises. Sometimes they can both be as a subject term, like it is here. Sometimes they can both be a predicate term. It can be reversed, right? Four different possibilities there. So F and C. So this is how you would begin to symbolize all this, right? So even up to this point, you've got some rules to follow, right? Put the middle term here, and then look at the conclusion. Put the predicate, the subject here, and the predicate here. Okay. Then you go in and represent the premises, right? You've got your format laid out. Now you just fill it in. So in this case, they're both universal affirmative. Universal negative. And so with the universals, we're always going to use that blackout technique, right? So here we're looking at the human circle and the fish circle. Right? And so then either by your own knowledge or by looking at the chart, how do you symbolize a universal negative? Well, what you're trying to say is the little triangle for no humans or fish. Let's see. Yeah, would it just be here though? This is the little triangle. Is that's the little triangle. We do want to fill that out, but what about this? If we left this blank, that would mean that some fish could be humans. Yeah, so we want to fill this out as well. Yeah, exactly. It's just like you look at your chart and you ignore the C circle, right? You got to have the whole middle part shaded right there. Like that, right? Because again, for this part, you can ignore the C circle, and what you want to make sure that there's nothing in this overlap left over. Nothing at all. It doesn't matter that there's another category over here. This says no humans are fish. That means nothing in the overlap can be allowed to remain open. There simply is no possibility of existence here, right? That's what no humans are fish is saying. There's no members here at all. We cannot put a little X anywhere here. There's not even at least one in here. There's nothing. No humans are fish. And notice that that's actually equivalent. This is one of these symmetric categorical statements. This is actually exactly the same as saying no fish are human. Right? See that? It's exactly the same thing. But don't worry about that. But do worry about this, right? No humans are fish. Look, if you just look on your chart, you have your subject term and your predicate term, and the whole middle area should be shaded. Even if there's another circle trying to join in on the fun, it doesn't matter. This statement, we're already committed to there being nothing in this overlap. There's nothing that is both fish and human. Nothing at all. No humans are cold-blooded creatures. Well, we do the same kind of thing, right? We're looking at the human circle and the cold-blooded creature circle. And we want to make sure that we're saying that there's nothing that's both human and cold-blooded, right? So there's nothing in the overlap. And you get this nice little symmetrical pattern, right? So we've represented both of the premises. Hopefully everyone could have done that. Now, do we see the conclusion? No fish are cold-blooded creatures represented here. Well, what would that look like? Well, we don't see it, huh? Cassandra is right? Because what would that look like? Well, we have to look at the fish circle and the cold-blooded circle. This says no fish or cold-blooded creatures. That's a universal negative. So that means there would be nothing in this overlap at all. But we have some space here, right? So the conclusion's not represented. If the conclusion were represented, all of this would be blacked out. So right now, the diagram, nowhere does it say no fish or cold-blooded creatures. It does not say that. So it's not represented here, so it's not a valid argument, right? If it were valid, that conclusion would just be read off. We would just see it. If that really were the conclusion, then this would already be shaded in. But it's not, so the conclusion's just not there. You shaded in this part right here, Maggie? Yeah, I'm not sure why. Because notice, that has to do with the F circle and the C circle. And the premises, none of the premises talk about fish and cold-blooded creatures. Right? We're only representing the premises. Right? This says no humans are fish. There's nothing here. There's nothing that's both human and fish. This says no humans are cold-blooded creatures. It says there's no humans that are cold-blooded creatures. But this here is left all open. Yeah, you don't plot the conclusion. Exactly. Do not symbolize the conclusion. That's the whole point of this. Symbolize only the premises. If the argument is valid, the conclusion will just show up on its own. So Maggie, you were right. You were correctly filling out the conclusion, right? If that were the task. But you should not try to fill out the conclusion. Very important. Because that's going to be your test. If the argument is valid, all you would have to do is plot the premises, and then the conclusion would already be there. Yes, yeah, please remember that. You're only representing the premises, and then you are seeing whether the conclusion is represented. The other ones we looked at, it was there. The conclusion was there. Here, the conclusion is just not there. The conclusion would be, like Maggie said, all of this filled out, but it just wasn't there. Yeah, exactly. If it was there, it would already be filled out for us. Exactly, Anna, that's right. The conclusion. Yeah, it might be right. If it's, I'm not sure. Let's see. What conclusion could we have here? No humans or fish. Um, would there be another conclusion that we could draw from this? I'm not sure you can draw any further conclusions from it. Um, no humans. Yeah, but again, cold-blooded fish is another category, right? That's a fourth category. you, you're all trying to make it more complicated. Yes. Yeah. Once we have the category sets, and there's 3 of them, you cannot change them anymore. You cannot add stuff to it. Exactly. It's got to stay. It's got to be one of those. It's got to be an all, some, or none statement. It's got to be a universal affirmative, universal negative, particular affirmative, particular negative, and it's got to just be one of those 3 categories as it's already been stated. Yes. So you keep it nice and clean and simple. So in this case, the conclusion did not show up, so the argument was invalid. Okay. Okay, let me do one just by hand. Okay. So I'm going to change the camera. We have a little bit more time, so I figure we might as well do a little bit more. Well, this is weird. Do you see the webcam right now? Do you see me? Because... Really? Yeah. That's problematic. I've been seeing myself the whole time, and it keeps saying... Well, earlier you could see... Well, you could see this, right? So you could see categorical logic. I want to share my webcam, and it just constantly says it's sharing, or it's starting, but it's not. So it's another weird little glitch that's happening. Yeah. Yeah. Yeah, it is really weird. It just has a little no symbol over it. It's just like stalling. Here, I wonder if I can just refresh my page and see what happens. Okay, let's see. You can see it now, I assume? Maybe not that well. It's very out of focus. I'll get it in a sec. Hold on. Okay, I know I have bad handwriting, but can you can you read it? I know it's a bit small, but are you able to see it enough? Okay, you can see it. Okay. Well, yeah, Maggie. So yeah, I hope even though we've had these problems, I hope it does help to have a little bit of the human interaction. I think it helps. I don't know if it helps academically in the long run, but at least it's just a bit nicer, isn't it? Okay, let me go. Okay, so I won't be able to see you type first. Although no, wait a minute, I can because I can just make sure. Okay, I'll wait 1 second for Anna to type. I realize that if I want the people watching this later to see it, I'm going to have to put it on a big screen of what I'm showing you, and then I won't be able to see what you're typing. Okay. Okay, so let me just do all of this without really stopping a lot because we're almost out of time. I just wanted to show you just step by step. Right. So here, first step is make sure that there's only 3 categories, right? Let's see, Socrateses, right? So I pluralize Socrates, right? That's one way to do it. As I said, you always have to make sure that it's in noun forms, right? And I also changed mortal to mortals, right? So I've changed everything to noun form already, right? Initially it was like this. Socrates is mortal since he's human, and humans are mortal. So you notice there's an adjective here and an adjective here, and there's a name right here, but it needs to all be categorical statements. So they need to be plural nouns. So I turned Socrates into a plural noun, human into a plural noun, mortal into a plural noun. Okay? See that? So now we're dealing with 3 categories of things. Right? So we'll just do the circles. I'm not very good at drawing circles either. That's already really bad because that leaves very little room over there. So let me do it again. Okay, slightly better. Okay. And then we look for the middle term, right? In this case, that's humans. Right, so we put, oh, and I put it upside down. I put the whole thing upside down. I like to think that this just makes you feel better, right? I hope it doesn't make you lose confidence in me, but rather, he makes stupid mistakes too. Okay. The middle term is humans, so let's put a little H right there. Okay. Then we look to the conclusion to see what we're going to put down right here, right? We're going to look at the subject and the predicates, and we're going to put those in the appropriate places. So Socrates is on the left, just as it appears in the conclusion, right? You can just follow that. Socrates is on the left, mortals is on the right. So I put mortals right here. Okay. Then I want to see if I can plot this statement right here. All Socrateses are humans. Well, let me look at the correct circles and ignore the other one. All Socrateses are humans. That means there are no Socrateses outside of the human circle, right? So here's the human circle. So anything else in the Socrates circle, I'm going to have to just black out, including what's overlapping the M circle, right? So all of this. How long do I want to spend shading this? I'm not sure. All Socrateses are humans. That means if you're a member of the Socrates circle, you're automatically part of the human circle, right? If you're in the Socrates club, you're also automatically in the human club, right? Because nothing outside of the human club is possible. This is all absence of anything. No Socrateses can live here. If a Socrates can live anywhere inside the Socrates circle, it's going to have to be somewhere in here. Okay? So that one's represented. Now, all humans are mortals. So then we just look at this circle and this circle. And what we're trying to say is that there's nothing in the H club that isn't also in the M club. So there's nothing in here outside of the mortals club. No humans, sorry, all humans are mortals, right? No humans are not mortals. All humans are mortals means there's no humans outside of the mortal circle. And again, this is just following the rules for each of those 4 types of statements. So if you don't know why I'm doing this, simply look at your universal affirmative type statements. You'll find that you always have the subject term all filled out except for what's in the predicate term, right? That gets to be left open. So then now we've plotted both of the premises, and then we want to check, does this represent the conclusion? All Socrateses are mortals. Well, we look at the Socrates circle. Where can Socrateses exist? Can they exist outside of the mortal circle? Anywhere outside the mortal circle? No. If there's a Socrates at all, it would be around here somewhere. And so it's represented. This says all Socrateses are mortals, right? This says if you're a Socrates at all, if you exist as a Socrates, then you're inside this club, you're automatically in this club as well. Right? Why is that? Well, because if we agree to both of these premises, which we represented as being true, then we're automatically agreeing to the conclusion because it just showed up all on its own. Okay, how's that? Do one more, or do you want to be done? Well, I also I should actually be done because I got to get ready for my other class. But I did put up some categorical logic exercises that I go through from last semester. I put it up. So I do the same thing there as I did right here, just sort of step by step going through. So I'm going to stop there. Did you have a question about the one we just did? Notice that one was just like the one we did a little bit ago. I think the first one was also 2 universal affirmatives. So it looked exactly the same, which makes sense. Yeah, I practiced it a bit. So what you could do is do the video that I've uploaded, and you could sort of pause it, right, before I go through it all. Pause it and see if you can do it, and then follow along with me and see if you're getting the same kind of thing. That's a good way to practice it. All right, everybody, good weekend. See you next week. Thank you.